this video, this will be the continuation on discussing concentration, particularly focusing on concentration problems. So this will be a 6-item problem. Um, these are pretty common type of problems in solving concentration. So from 1 to 6, let's start with an easy type to a hard type. So number 1. So the student dissolved 7.45 grams of lithium chloride in enough water to make 350 ml of solution. What is the molarity of the solution? So let's understand first what's the meaning of molarity. So molarity is a unit of concentration, okay? And this is the most common unit used um, for describing the concentration of a solution, and it is expressed in m. Okay, and it can be expressed as well as mole per liter. Okay, which is mole of solute per liter of solution. Okay, solution, not solvent. So if the volume given here is the volume of solvent, you need to find the volume of the solute. Therefore, adding that, then you have the liter of solution. Well, in this case, we were given the liter of solution, which is 350 ml. And we have the solute, lithium chloride. It is in grams, and we need it to be in mole. So let's plan this out. So the given, we have the solute, right? We have 7.45 grams, and we want it to be in moles. Okay, to get this. And then we have the ml of the solution, which is 350.0 ml, and we want it to be in liters. So this is simply conversion. We were given the molar mass. So if sometimes this is not given, so you must use your periodic table. But in this case, we were given the molar mass. Okay, let's do dimensional analysis. Well, in this type of problem, I always start with the given mass, because we were asked what is the final concentration. Okay, okay, 7.45 grams. What is the molar mass of lithium chloride? 42.39 grams in 1 mole of lithium chloride. Okay, so we got the mole, and now we want the liters, but we have 350 ml. So we want to convert it to liters. So 1000 ml is 1 liter. Okay, so we can cancel that. Then we get, I think we should change the color here. Then we got um uh, moles per liter. So we can calculate 7.45 times 1 over 42.29 times 1 over 350 times 160. So we got 0.502 moles per liter, or 0.502 m. That's the same thing. Okay, this one is easy, and this one is pretty common type of question, especially in introductory part of solving concentration. So this one is easy. Next, okay. You were tasked to prepare 500 ml of 0.250 molar calcium nitrate using calcium nitrate tetrahydrate, and how many grams of the hydrate do you weigh out? So this type of question is tricky. Okay, we must take note. we want to get, okay, if you understand, let's understand first the problem, okay? They said that you were tasked to prepare, let's say this one, you were tasked to prepare this one. This should be 0.250 molar CaNO3. So, okay, this is 500 ml. And the problem is your reagent is not calcium nitrate. You are using calcium nitrate tetrahydrate, which is this is different, right? It has 4H2O. You're not using this directly. So you are using this, okay? You're using this reagent, CaNO3 2H2O. And it asks us how much in grams should you weigh, okay? Because when you um, prepare a solution, you should take like a gram of this, okay, to get a specific concentration. And it asks us how much gram should you weigh with this one, okay? Not this one in this form, in its hydrate form to create this, okay? How many grams should you get from this to prepare this? And the problem is it's not the same because this is hydrated and this is and that is pretty common, especially in lab work, because reagents are typically hydrated. And that's what makes this question tricky. So with this type of question, let's start with the concentration, final concentration we should prepare. Okay, you are tasked to prepare 0.250 molar or 0.250 moles per liter, and that is moles of calcium nitrate, not calcium nitrate tetrahydrate. Okay, then now you have a volume here, right? So 500 ml is basically 0.500 liters. Okay, and you can cancel that. Now you got the mole. You want the grams of calcium nitrate tetrahydrate, but you have calcium nitrate. So let's find its stoichiometric ratio. So 1 mole of calcium nitrate is how many moles of calcium nitrate tetrahydrate? How many calcium nitrate is in calcium nitrate tetrahydrate? One, right? Yes, it's only one. The only different thing is it has an extra water, but we are asking for the ratio of its calcium nitrate, not with water. So this is also one. So it's basically 1-to-1 ratio. Okay. Now, 1 mole of calcium nitrate tetrahydrate, how many grams? So now we are asked the molar mass. The molar mass of calcium nitrate is given. So we know this 164.09 grams. Plus, we have an extra water here. So if you look at the periodic table, water is approximately 1 and oxygen is approximately 16 or 15.999. That's just 16. So we can say that water H2, so that's 2 times 2, 1, that would be 2 plus 16, that would be 18. Okay. And then, so 1 water is 18. So 4 times 18 because this is 4. So that's water. So now we get the grams. And now we can solve for, because this can be cancelled and cancelled. And we're left in grams of calcium nitrate tetrahydrate. Okay, so 0.250 times 0.5 times 1 over 1 times 164.09. Okay, wait. 9 plus 4 times 18. Okay, that would be 29.51 grams. Let me check. 0.250, 0.5, 164.09 plus 4 times 8. Okay, yeah, we got 29.51 grams. So, um, if we picture out how to create this, first, you should get 29.51 grams of this calcium nitrate tetrahydrate. And then you put it in a 500 ml volumetric flask. So this one is the volumetric flask. And then fill it to the um, mark. And then you will create 0.250 molar calcium nitrate. Okay, that's easy. Next, okay, what is the concentration of a 600 ml solution when it was prepared by diluting 25 ml H2SO4 with an initial concentration of 12 molar? So there is a word here, diluting. So diluting um, basically means adding more solvent or in general um, making the solution less concentrated. Okay, if we recall, right, the concentration is amount of solute over amount of solvent or amount of solution, right? So when we increase the amount of solvent, the let's say C is the concentration. When we increase, let's say you increase this amount, okay, then C decreases. When we increase the solute, C increases. Okay, so in the principle of dilution is just adding more solvent to create a less concentration concentrated solution. Okay, so in this problem, um, we're going to use the dilution principle, which is C1 V1 equals C2 V2. Okay, C1 here is the initial concentration, and V1 initial volume, C2 final concentration, and V2 final volume. And this is pretty straightforward. Okay, so if we want to find C2, which is in this case, right, what is the concentration of a 600 ml solution? So 600 ml is our V2. And when it was prepared by diluting a 25 ml H2SO4. So you started from 25 ml, so this is V1 with an initial concentration of 12 molar. So this is C1. Okay. Now we know the V1, C1, and V2. We can calculate for the C2. Okay. So C1 V1 is equals to C2 V2. This would be C1 V1 over V2 is equals to C2. Therefore, C2 is equals to what? Your C1 here is 12 molar. And then your V1 here is 25 ml. And your V2 here is 600 ml. Then solve it. 12 times 25 over 600. That would be 0.5 molar. Okay, so that's easy. So as you can see, we started, okay, the initial, right? Initial, we have 12 molar and it was 25 ml. And now that we add more solvent, producing 600 ml, it had lower concentration, which is zero point 0.5 molar. So that's the dilution process. In the final concentration, we expect it to have a lower concentration. Okay, so next, a hydrogen peroxide solution is labeled 3% M over V, meaning 3 grams HO2 per 100 ml solution. What is the molarity of this hydrogen peroxide? Okay, so this is a very kind question, right? It, it even gave us a meaning that 3% M over V is 3 gram per 100 ml. But let's discuss what does 3% M over V mean. And this is a pretty common way of this of reporting concentration, especially on products. You can see, so okay, there are three types to express percent. Okay, there is percent M over V, like this one, percent M over M, and percent V over V. So M stands for, okay, let me change the color. So M is mass and V is volume. So when you say percent M over V, so it's a percent of mass in a volume. Okay, and a way to be an easy way or a convenient way to picture this is always picture the denominator as 100. So for example, in this case, we have 3 grams HO2 per 100 ml. So the numerator would be the percent value, which is 3, and in this case, M grams, and then we always put 100 ml. That's the more convenient way. Okay, so when it's M over V, X grams per 100 ml. M over M, X grams over 100 grams. V over V, X grams over 100 ml. Oh, sorry. This is ml. Right. Then this is X ml, sorry, per 100 ml. Okay. So when I say 5% V over V, it's simply 5 ml over 100 ml. Okay. Alcohol usually is 98% or 70%. Let's say 70% V over V. So it's 70 ml per 100 ml. Okay. So that's it. So let's solve this problem. So it says that we have 3% M over V and we want to convert it to molarity. So we want percent to molarity. So let's start with the percent. Let's change color. So 3% M over V converted 3 grams per 100 ml. So we want to convert it to moles per liter. So this is simply converting the 3 grams to mole and 100 ml to liters. Let's convert this to moles first. So we have H2O2 as the solute. And if you look at the periodic table, H is 1, so 2 times 1, and O is 16, plus 16 times 2. So that's 1 mole H2O2. So we got the mole. And let's convert this to liters. Okay. 1000 ml, 1 liter. So we can solve it. This one is in grams. So this would be cancelled. So 3 over 100 times 1 over 2 plus 16 times 2 times 1000. That would be 0.882. Okay, so that's why products, usually use percent because you can picture it out rather than in molar. You can really picture out 0.882 molar, right? Okay. Next, a water sample contains 25 ppm of calcium ions. Assume the density of the water is 1 gram per ml. What is the molarity of the calcium 2 plus ions in the solution? Okay, so this is another unit for concentration. Okay, these are parts per million, which is commonly used when the concentration is very small. That it would be 0.000 and then go on. So we have parts per million, which is 10 to the negative 6. Okay, when your concentration is 10 to the negative 6, that would be very small for a molarity. So we usually use um ppm, or we also have parts per billion, which is 10 to the negative 9 parts per trillion, 10 to the negative 12. So these are useful for small um small concentration um values, no? So these are used to report that. So ppm and ppm, ppb, ppt can be reported in mass over volume or in mass over mass. Okay, so these are useful conversions. Okay, so you must remember this. Parts per million is milligram per liter. Parts per billion, microgram per liter. Parts per trillion, nanogram per liter. So as you can see here, it's always per liter, right? And what changes is only milligram, microgram, nanogram. And that's the same thing for m over m. This would be milligram, microgram, and nanogram. And the key difference is just kilogram. But all of these are kilogram as well. Okay, so this is very simple to memorize. This milligram, microgram, nanogram, and if it's m over v, that's just per liter. And if it's m over m, that's per kilogram. Okay, so let's solve this problem. So in the problem, we want, it says a water sample contains 25 ppm of calcium ions. Assume the density of water is 1 gram per ml. What is the molarity of the calcium 2 plus ions in the solution? So given this, we are asked to get the molarity. So from ppm, which is milligram per liter, to molarity or mole per liter. So we want to convert this milligram to mole. That's it, because we have the liter here. Okay? Okay. So let's start, since the concentration is given, let's start there. 25 ppm or 25 milligram per liter. Let's convert this to grams. 1000 milligram is 1 gram. Okay, then let's get the mole. 1 mole of Ca2 plus is, it's given here, 40.08 grams. So now we can cancel milligrams and grams. And now we can get the molarity, mole per liter. So we'll solve 25,000 times 1, 40.08. So that would be 6.24 times 10 to the negative 4 molar. So as you can see, it's very small. That's why we use ppm. This one, 25 ppm, is very friendly to the eye than this, 6.24 times 10 to the negative 4. So sometimes if it's very small, we can just use ppm, ppb, or ppp. Okay. So okay, this is ppm, ppp, ppt. Okay. Next, so this will be the last question, and I think the hardest one. Okay. You have a 2.50 molar KCl stock and 0.500 molar KCl stock. You want to prepare 250 ml of 1 molar KCl from both stock solution. What volume of the 2.50 molar and 0.500 molar KCl should you mix to prepare the 1 molar solution? Okay, so let's understand the problem first. So you have the 2.50 molar KCl. So this is a stock solution. And you also have a 0.500 molar KCl. So they are the same chemical but different concentration. And you want to make this 1.00 molar stock. Oh no, 1.00 solution KCl as well, but with a volume of 250 ml. And the problem is you want to make this solution out from this two stock solution. So you want to combine this one, and this one to create this. But the problem is you want to know how much or what volume should you have from the 2.50 molar and what volume should you have from the 0.500 molar. Okay, this is problem. So this is what we want to solve. So this is pretty hard, okay? But let's try and solve it. Okay. So this has a clue. They said assume volumes are additive. Volumes are additive. So let's set this 2.50 molar as stock A. Sorry, A. And this one is stock B. And okay, so we know that the final concentration is 250 ml. Okay, and then the volumes are additive, so it should be the volume of stock A plus the volume of stock B should be 250 ml, right? So this is true. Then 250, sorry, 250.0 ml minus VA is equals to VB. Okay, so I just transpose it here. So now we know the value of VB. Okay, but this is still not quantifiable value. So we want to relate it to another, um, let's say another value out from this info. So when the voids were additive, let's assume the moles are additive as well. And we can calculate the mole Okay, mole of the final solution. What is the final solution? So the concentration is 1.00 molar. If it has a volume of 250 ml, that is just 0.250 liters. Okay. Now, 1,000, 1 mole per liter times 0.250 liter is just 0.250 mole. Okay. So we have 0.250 mole in the final solution. Okay. Now, we can do this as well with our stock solution. So we can calculate for the mole for stock solution. So 2.50 molar times VA, which is our concentration of VA, okay, plus 0.500 molar times VB should be equal to the final mole, 0.250 mole. Okay, now what's next? Well, we know that the value of VB is 250 ml minus VA based from this, right? So let's do that. So we can 2.50 molar VA plus 0.500, and then VB would be this one, 250 ml minus VA is equals to 0.250 mole. You know what? Let's make this 0.250 liters. Okay, that's the same as 250 ml, 250 liters. Okay, now we can multiply it. So we get 250 molar VA plus, okay, this one will be distribute, this minus VA. So 0.5 times 0.25 is 0.125. So this one is in mole, okay? And then molar, and then this would be mole. Molar times liters, okay? Minus 0.500 VA, okay, is equal to 0.250 mole. Now we got two terms here. We got um, MVA and mole. So let's um, put the similar terms in the same side. Okay, so 2.50 molar VA, this one minus 0.500 molar VA is equals to 0.250 mole. Then let's put this to the other side, minus 0.125 mole. So 2.5 minus 0.5 is 2. So that would be 2.00 MVA. And 0.25 minus 0.125 is 0.125. 0.125 mole. Okay, so if we want to find VA, 0.125 mole over 2 molar. And molar is mole per liter. So cancel this. We are left with liter. So 0.125 divided 2, we have 0.0625 liter. Okay, so now we know VA. So VA is 0.0625 liter, or which when expressed in ml It is simply 62.5 ml. To get VB, just simply minus. Okay, we can use this VB. So 250 ml minus VA, which is 62.5 ml, is equals to what? 187, 187.5 ml. Okay, so this is the final answer. Okay, that was long. Okay, so this one is like the hardest type of question. So your professor might do this to you if he wants you to struggle, or he or she, I don't know. So okay, that's it. Thank you for watching, but I have some assignment. Okay. So these are assignments, so you can pause the video if you want to solve for yourself. So I'm gonna answer this in the next video. Okay. These are 8 items. So practicing calculation can improve your performance in solving concentration. So okay, that's it. Thank you for watching.